Welcome everyone back, and in today's lesson we're really going to start doing some refactoring. I want to move this toward like some type of graphic engine and eventually evolve it into a gaming engine and something that could probably run on an Electron, so we can make desktop games and make it both portable on the web along as desktop, Mac, Linux, the whole spiel. So I thought this might be a good time to start refactoring some of the code. Certain things I feel like is a little difficult to deal with, kind of hard to manage. So simplify a couple of steps. So the first thing we're going to start with is shaders. The way I've been doing shaders lately is kind of been a pain in the butt. So I thought, let me refactor it, make it easier since now we've gone through a lot of shader code. Let's see how we can simplify the process. So let's start off first by going into our shader.js file. So we're going to start off by building a new object called shader builder. This is going to be slightly different compared to our original shader class. This one will actually be able to handle certain things like textures. Our previous class didn't have anything to handle textures at all. And then in the previous object that we kind of had to build setter functions for every uniform. So it was kind of a pain in the ass to really handle it, especially for every time, especially if you run a prototype. It slowed me down. So this object is going to handle a lot of things to make it a lot quicker to kind of prototype things. So let's start first. Line 2 with our constructor. We pass in our GL context and we pass in our two shaders. Now I do kind of a little hack here on line 5 to check to see the length of the string. If it's less than 20, I'm only going to assume it's the script tag DOM name, and if it's not, it's actual shader text. So it's kind of a little hack. I put a little to do here. Maybe I should check to see if there's actually new lines. If there's a new line, it's most definitely going to be shader code, not just DOM name. But for now, this is a quick hack to really just distinguish between passing a DOM name or passing an actual code. And so at this point, we create the program depending on which one we're doing. And, by line 8, we have the if statement. So we do the normal stuff. We turn on the program by using use program. And now we have two private lists, a uniform list and a texture list. They're both going to be treated slightly differently. The uniform list is going to be a key value structure. It's kind of like a struct, but I'm using an array instead. And so the key will have the uniform name that's in the shader, and then the value will be a structure that has the location and what type it is. And the texture list is another array, but this one's going to be used as an array with a numeric index. And it will have our textures that are texture uniforms from that's inside our shaders, and the structure that would be the value would be a location and the texture ID of that we kind of loaded into the GPU. And now I have the two settings on line 14 and 15: no culling and do blending. That's something that was always part of our model class, to turn on and off certain features. But I kind of noticed that sometimes I have a model set a certain way because that's how I want it. But when I'm debugging or I'm prototyping, I want to turn it off or turn it on. So I want the shader to have that ability as well. So this one makes it easier for me just to turn it on and off at the shader level without me actually going into the model class and turning the features on and off. So to me, this would be just a lot easier. Moving down, we're going to move on to some of the two main functions in this new builder class. It's our prepare functions. We have prepare uniforms and prepare textures. What I'm doing is I'm using the arguments array. So this way I can pass in as many arguments as I want. It's kind of like an array. Instead of actually building an array and passing in an array, I'm just going to pass in an unlimited amount of arguments. And by doing so, there's going to be in a specific order. For perform uniforms, it's every 2. So the first the first parameter you pass in, or the first argument you pass in, would be like the uniform name, and then the next one would be uniform type. And then you kind of repeat the process: uniform name, uniform type. So I kind of have an example on line 22 at the end, which I pass in ucolors, and then the next one would be 3FV, which is a 3-float vector. So I know which type it is. And And that's all the function does. At line 24, it checks to make sure they're in pairs. So it has to be at least divisible by 2. Line 27, I'm looping through all the arguments and looping them by groups of 2. And that's why there's an I plus equal 2. And then line 28, I am just getting the location of the uniform that you're passing in. And the next line, if the location does exist, then we save it into our uniform list with our little structure. We save the location, and then we save the type. And it's pretty much a similar process with prepared textures. Line 36, we have, we check making sure it's in pairs. Line 39, we're looping in groups. And then line 40, we're actually going to go check the GL texture cache to see if the texture name exists. If the texture name exists, then we actually go get the uniform name of that for that texture that we use, and then we save it to our texture list with the location and the texture ID that's from the cache from loading textures. So this is how we're going to prepare uniforms. This is going to handle a lot of that stuff for us really quickly. So instead of us writing the code in our structure, in our extended class, all we do is kind of just pass in all the information into these two functions, and it kind of generates everything that we need. It gets the locations, and we can then reuse those arrays to actually set those values. And speaking of, if we go down, we're going to go to our set uniforms function. And again, we're just in the same theme. You're going to use the arguments array so we can kind of just set all the uniforms in one go instead of having like 10 set functions. We'll have a single set function that we kind of just pass in information kind of as an array, and it's a group of 2s. So we're going to pass in the uniform name, and we're going to pass in the uniform value and groups. So about line 57, we're just looping through in groups again. Then we're going to check to see if the uniform name exists in our uniform list. We give you an error message, and we kind of exit out if it doesn't. But, that's at that point, we're good. And then on line 61, we check to see what type of uniform is it. Is it a 2-vector float, 3-vector float, a matrix 4? So based on what type it is, we have to use different GL functions. That's kind of the reason why I need to save the type, because there's multiple functions based on the data type. So in case there is no data type that's unknown, or you misspelled it, or the case is different, we give you an error. And that's it. That's all it is to do a set uniform function. And this way we can actually set 10 or 20 uniforms in one go without actually creating all these set functions that we've been doing in the previous lessons. And then at the end of what I have on the screen, line 76 and 77, it's our regular activate and deactivate, turning on this shader and turning off this shader. So if we move on some more, we have our dispose. We haven't used it yet because I haven't been doing any unloading of shaders, but down in the future when we make a system out of this, we're going to need a dispose. And then we have our pre-render. And our pre-render in the original base class didn't do much. It was something we extended and then used it to handle textures. Now our pre-render actually does a lot. In the previous way, we always had to activate our shader, and then we had to then do other things. So I thought, what? Why don't we just save some time and actually have pre-render actually activate our shader? So on pre-render, we activate our shader. That's what we're doing in 87. So if I'm calling the activate function, I'm going to save myself a function call and just do it directly. So, just save one extra function call. Speed up the process, just a tiny, tiny microsecond worth. Let's see. And then pre-render again works like the other functions where we pass in an array of arguments. And pre-render is going to work just like set uniforms. So pre-render can actually work as like set uniforms as well. So it's kind of like it's a double function. It uses we can call set uniform, then do pre-render, or do pre-render and set uniform, but might as well just save ourselves the hassle and just use pre-render as our set uniforms as well. So you can do pre-render, and then if the arguments array is greater than 0, we just pass that argument array to our set uniform. So we can, pre-render will activate our program. It will apply our uniforms if there are, And then in the final step on line 95, it actually turns on all our textures and applies them to their correct uniforms. So pre-render actually does a lot. It actually does handle a lot of the work for us, which is really great. And then we finish it off with our render model class, and our render model class is practically the same from our previous thing. We set our MB matrix, and then we have line 113. We're checking certain features if we're going to turn them off, and like again we're checking to see if the model wants those features on or off, or if the shader has those features on or off. So that's the only big change we've done. That's the only change I've done to this render class, render function. And one thing you might notice, I'm actually spelling model correctly. In the very beginning, I spelled model wrong because I do programming during the day for work, and I create a lot of models. MODALs. So I'm so used to typing that I didn't pay attention that that's the incorrect spelling for what we're doing. It's MODEL. And other people have pointed that out, and I kind of, a race started and I couldn't do anything about it. So now I'm going to do something. Since I'm rewriting things, I might as well get the correct spelling on certain things. So this ends the shader.js file, and this is going to be our new builder class that will handle our shaders. Once we get to the HTML page, you'll probably see how easier it is to actually have a shader initialized and used. So that's it for this file. Now we're going to move on to something else that I kind of need to kind of simplify. And lately we're going to do a lot of things with textures. Textures become a very important part of 3D graphics, because that's really how can you add certain looks to it. And the way we've been doing textures lately is that we do an image tag, and then we get the image tag, and then we pass the information to GL to kind of save the image as a texture, and then we get the texture ID and save it to the cache. That's a lot of work, and especially if you want tons of images, then you have to create all those HTML tags. And when we were doing sky maps, that was really a pain in the ass. So and then especially since we're going to build an engine out of this and do games and stuff, we got at some point going to need to pull in a lot of our resources. Maybe some of our shader classes or shaders will be stored as text files that we download. Definitely a lot of textures. A lot of our models are going to be files that we need to download and then get them ready for rendering. So I'm going to start creating a resource object. So it's going to be kind of just a static class that kind of just handles things on a global scale, because that's really how we need it. So, create a new file called resources.js, and we're going to create a new class called resources. And we're going to have a static class at the function at the very top called setup. And all it is because, I need to set it up with the GL context and a complete handler. And on complete handler is I'm going to handle, it's an event handler. So we're going to pass in a bunch of things that we want to load up, like from the server or from a local drive. And then when it's all done loading up, call an event, because we're going to set a startup is going to be now two separate steps. We're going to set up the system. We're going to get our resources. And then when the resources are done downloading, then we're going to go to the second step is we're going to create our models, maybe create our shaders, and then start the render loop. So that's going to be our new process of starting up our graphics engine. So that's pretty much what setup is for. It's really just to set up our context and our event handler. And then line 11, we have our start function, which just starts the download queue. And that's all it does. It just checks if the length of the queue, if there's at least an item on there, we call load next item. And the way it's built right now, it only loads one item at a time. In the future, I'll probably build it up so we can load 2 or 3 or 4 things at a time. If you're downloading from the internet, you need to start streaming certain groups. To do that, I need to keep track of how many items are currently being downloaded. I just didn't want to go through the hassle of building all that. Like for prototyping, this will actually save us a lot of time, and we'll deal with the more complicated handling multiple download streams later in the future when we need it. But for now, this actually is a great step forward to actually simplify getting and loading our textures. So then we're moving on to load texture, and here I noticed I put our name and source, because it originally started off as a single load texture, but you can name the arguments if you want, but in the end of the day, I'm still using the same idea I've been using in the shader builder, which I'm going to use the arguments array in groups of 2. So in this example, I kind of named the 2 positions, and you just repeat those positions, name and source. So since I'm loading a texture, I'm just pushing to the queue a static type, and I'm telling the type is an image. We're giving it the name of the argument, because when we load up a texture, we need to give the texture a name to save into our cache, so we can reference it back in our code. And then the source would be the path to that image. And of course, we return this because we're going to do chaining. So that's our load texture. So we're going to move on to our next function, which is the load next item. And all it does is check the queue. If an item exists, we start downloading that file. And if, this is where it tells us if the queue is empty when this function is called, we're just going to call the onComplete handler, and that's it. So on line 35, we just pop the queue. We just basically, the pop function just grabs the first item on the array and removes it from the array. So this way, we are clearing out the queue as we're downloading things. We check the type. If we know if it's an image, we kind of save our queue data, because we kind of need to reference back the name of the image that we save into our textures. So that's why I'm kind of just saving the queue data into the image tag. We're setting up its onload event. So when the image is done downloading, it will call our onDownload success event handler. And then on image abort and on error, we call our download error. And then at the end, we put in a source, because the moment you put in the source, the browser will start downloading the file. So that's why we did it last, because I want to make sure I have the data and the events all set up before we start downloading. So that's pretty much how we actually start downloading from the queue. Then we have our 2 events, one for success and one for error. And since you're applying this event to an object, it takes that object's this event. So when I say this, it's actually this download success function is part of the image file that the image object we just created, the downloader. So that's why I'm saying, is it this the instance of image? So if it is the image, then it should have the queue data that we put into it. So we grab the queue data, and then we call our GL context and tell it, okay, here is the name, and this is the actual image tag. Here's the image tag, and load the data into into our GL GPU. And once it's done loading our, the image into our GPU, we call load next item, which basically just calls the next item for download. So as soon as this is done downloading, it downloads the next item. And then we have on download error, which just gives us an error message that something happened downloading this image, and then just it continues downloading the loop. And that's what the resources file does, and that's all it really is. And at the bottom, you'll see, since it's a static object, I have to add these properties at the end. So there's our queue, there's our complete and our GL context. That's where everything exists, since these are static properties in our object. And that's resources. This will now handle our downloading our textures for now, and hopefully down in the future we'll build it to download model files. So we don't need to include the object files in script tags, because if the Pirate Girl one was huge, it was a pain in the ass to manage. It'd be great if we could just download that file and then parse it and then render it, instead of just copying and pasting into script tags. So that'll be in the future, where we'll start dealing with more models again. I'll probably add into the resources.js file to actually load these models in for us. So, but for now, textures are going to be the big deal for us for the next couple of lessons. So this is why I wanted something to start with to make things easier for us in the future. Now we're going to start moving on to our HTML page. And this is going to be kind of like our new template for the next few lessons. So everything's brought down to the bare bones. I only bringing in the JS files that we need. And we got our new resources.js file added to the list. Then on line 24, I kind of simplified the list of variables that we're going to need down the line for just prototyping and for our lessons. Then moving on, we have our load event. And this is, what a normal load event would be. So we're getting our context, we're getting our camera, we're setting up our grid floor, and we're setting up our render loop. And then at the end, this is kind of a new thing. We're actually calling our resources. We're setting it up. We're setting up the object, and then we're asking it to load the textures. So we're actually loading texture 001, and this is the file. We're going to load the first texture file that we had in our lessons, and then we call start. And that's it. And so when the page loads up, we start setting up our system, and we start loading our resources. And when the resources are done, it'll call our onReady function, or our callback. And here's our onReady callback. And it kind of just finishes the rest of everything else. So when everything's all ready, this is our new shader builder. And instead of extending it and then adding all the function, this is all it takes to build a shader. And I know originally I came up with the idea of kind of just doing some static global names for certain things. And I'm probably walking away from that because maybe I want the freedom to just rename things based on shader. Maybe certain names I kind of not happy with, so I kind of want to change them. So I'm not going to set things in stone that much. For attributes, they're still static, but for our uniform names, they're not. So that's the only tricky thing is the model view matrix needs to be a static name because we still need it for our model. So that might be the only thing that needs to stay static. But for now, what we have is pretty good. So we're setting everything up here. We got our passing in the DOM names. Then we're calling prepare uniforms. Those are the main uniforms we have for our shader. Then we're going to prepare our textures. That uTexture is going to be our uniform name, and texture 1 is the name of the resource that we just downloaded. That's if you look in the previous screen. And then at the end, we're going to set our projection matrix. Originally, we passed in our projection matrix at the constructor of our shader. Now I'm not doing that anymore. It's a uniform. I'll just treat it as a uniform. Maybe certain shaders might not need the camera projection matrix. If we're doing UI stuff, we probably don't need that. So no point in having that being kind of default. So in case we make like a UI shader, we definitely won't have that kind of matrix. And then it's your regular stuff. Line 55, we load in our model, and then line 59, we kind of just start up our loop. And then in our loop, it's pretty simple. We do our clear, we update our camera view model so we can use it for everything. Our grid floor, all it takes in is our camera, so it draws our grid floor. Then line 75, we have our new shader builder. And remember, pre-render also works as set uniforms. So we're going to pass in our camera matrix, just like how we do it with set. But it also turns on our shader and prepares our textures for us and everything else. So we're good to go. And then after that, we just render our model, and we just call it the model that we want and just pre-render it and call it a day. And then moving down, this is our shader. And this is a very simple shader. All it does is just takes in a texture for us. And I'm doing something a little special. Right now in line 105, I'm multiplying our UV coordinates by 1.5. I'm actually scaling up our UV coordinates. And here's the trick. You can upscale UV coordinates to make textures tile. So here's an example of what it looks like after all said and done. Here's our cube, and it has our textures, right? And if you remember, our texture normally has just the 4 squares, but this one now has 9 because we upscaled it by 1.5. So I'm actually getting an extra half texture on all sides. So you can upscale it as much as you want. Try multiplying by 10, try multiplying by 20, and you'll see that all you're doing is tiling the textures. And that's pretty much it. And I know there's seams here, and I'm trying to figure out how to do it, but it has something to do with having 4 planes. Sometimes I've read that if I use like a cube map, then you can kind of get rid of seams or have a special texture made specifically just for cubes. All the faces this way, there's less seams in it. I'll try to explore in the future possible ways to kind of get rid of seams when dealing with cubes. But for now, this works out pretty well, and probably because the texture is kind of low quality anyway, so it's got issues. So that's pretty much it. That's all refactoring doing for now, for today. We got a new shader builder, we got our resources that we load in dynamically, and I showed you how to tile textures a little bit. In the future lessons, we're going to start dealing with more texture-related things, and then move on to terrains. So that's pretty much it. And like I said, we're going to move this toward some kind of engine that we can kind of use for the web and for the desktop by using systems like Electron. If you don't know what Electron is, look it up. It's really cool. It's kind of like a Chrome browser set up so you can turn web applications into desktop applications. It runs on Chrome, it runs on Node.js and things like that. So it's a pretty cool idea I came up with over the weekend, that maybe I can just turn a web-based system into a game that runs on the desktop, because it'll probably run faster if all the resources are locally, and you can have certain things. So I thought that might be a cool idea. I'm still trying to figure out a name for the engine, because I don't want it to be just a game engine. I want it to be kind of just a graphics engine, because maybe I wanted to some 3D applications, like something to create homes with, make a house you can kind of walk around in and kind of just visualize a home. I would like to do some VR stuff with it too. So it's gonna be a long ride, and it's gonna be a slow process in building up this system, and hopefully you guys enjoy it. And feel free to comment and give me ideas of what directions you want me to go. I was gonna go straight into terrains, but I decided to do textures first, because there's a couple of cool things we can do with textures that I want to explore first. I want to explore masks. I want to explore what's the other thing? It's related to Minecraft. It's this way you can, I forget what it's called. Oh, atlases, texture atlases. I want to do texture atlases really quick. That should be quick and easy to do as well. And I've been researching on how to apply textures to objects that don't have UVs. So this way you kind of generate your own UVs in a certain way. It's supposed to be really good for terrains, so this way textures don't get stretched out. So things like that. So that's kind of the reason why I'm kind of doing textures first and then moving on, because a lot of our texture stuff can then be easily applied to our terrains. So once we have our terrain built, we can do all these crazy textures things to it. So that's pretty much the order of the process I'm doing right now. So that's it, and I'll see you guys in the next lesson.